Okay, I think we can start the class. Okay, so in the last class, as I can remember, we have discussed assumptions made in working stress theory. Is it? Hello? Okay, hello? Okay, please respond in either in chat box or you can speak. Okay. Okay, as I can remember, in the last class we have discussed about the assumptions made in working stress theory. Is it? Yes or no? Hello?
Sir,
Yes.
so we studied about the self-reinforcement in
Yeah, and we have discussed the assumptions also, is it? In working stress theory.
yes, yes.
Yes. Okay, so let us continue our class from the last class. Okay, so now I will share my screen. Okay, you will tell me whether you can see it or not. Or can you see the screen now? Hello.
Yes, sir.
Okay, okay. So we are discussing about singly reinforced beam, and I hope all of you have got a clear idea about singly reinforced beam. That means if you provide reinforcement in only tension side, then we will say that the beam is a singly reinforced beam. Okay. So now in singly reinforced beam, we can have different types of problems. Okay. So based on the values given in the question, we have to find out different other values. Okay. So first, let us see what are the different types of problems we will face in this singly reinforced beam. Okay. But today and in next classes also, next few classes also, we will discuss briefly about working stress theory also. Okay, in working stress theory, how we will analyze a single reinforced beam or double reinforced beam. These things we will discuss. Okay, so now we are discussing about single reinforced beam. So as you can see, figure 2.4. In figure 2.4, you can see a singly reinforced beam is given. Okay, the width of the beam is given B, and I think in the last class I told you what is this small d. This small d is known as effective depth. This height is this length is known as effective cover. These three dots indicates the reinforcement which are present in our in the beam. Okay, so this small n is the depth of neutral axis. Okay, this small n represents the depth of neutral axis. And I hope all of you know what is neutral axis. Neutral axis is the imaginary axis at which both tension and compression are same. That means both tensile stresses and compressive stresses are same. Okay, so this is the imaginary line. So if this height is n means depth of neutral axis, then this height will become b minus n. I hope all of you have understood this one. In the last class, we have discussed about this diagram. This is our stress diagram. Okay, this is the stress at the topmost layer, which is the maximum compressive stress, and this is the maximum tensile stress. Okay, in the last class I told you why this is our solid line and why these are dotted lines, because the entire tensile stresses will be taken up by steel. That's why this line is drawn along the center line of the string. Okay, and this whole portion is our concrete, and concrete will take the entire compressive stresses. That's why these lines you can see these are our solid lines. Okay. Okay. So now this sigma CBC, this stress total, this maximum stress is known as sigma CBC. In the last class, I told you what is sigma CBC and how can you find out sigma CBC from I square. Okay, and this is our sigma S. Sigma S means stress in steel. Okay, so stress in steel. Did I tell you how to find out sigma S in the last class? Hello, did I tell you?
No, sir.
Okay, so now if you have IS 456 with you, you can go to table number 22. All of you go to table number 22. Go to table number 22. This table. You will see this table. Table 22 of IS 456. Can you see the screen? All of you, please open the PDF. So from this table, you can find out the value of sigma st. Sigma st means maximum permissible stress in steel. Okay, it is written also permissible stresses in steel reinforcement, okay, which will be indicated by sigma st. So in this table, you can see in the left column, you can see a serial number, then type of stress in steel reinforcement. Okay. So now we are providing in single reinforced beam, we are providing reinforcement in the tension zone. So we have to see only these values. Okay, not this compression in column bars, only this tension value. Because in single reinforced beam, we are providing our steel only in the tension side. So we will see this value, only this value. Okay. So now if mild steel is given, mild steel is given, that means if you are using Fe 250, then you have these two values 140 and 130. Okay, you can choose these two values. Okay, so now for any problem you can't have, or you can't take 140 or you can't take 130. There is another criteria here, you can see here, up to and including 20 millimeter. That means if the diameter of bar is more than 20 millimeter, then you will choose 130 for mild steel. Okay, if it is given that you are using mild steel bar of 25 millimeter bar, then sigma st value will be 130 newton per millimeter square. And if simply it is mentioned you are using mild steel bar, then you have to use this 140. Okay, I think all of you have understood this value, how to choose this. Hello, do you understand what I am saying? That in case when we will solve the numericals, then it will be more clear. But now you just listen this one. If you are using mild steel bar of more than 20 millimeter diameter, then we will choose the value 130. And if you are using a mild steel bar of less than 20 millimeter diameter bar, then the value of sigma st will be 140. Okay. Then if you are using high yield strength bar, that means if you are using Fe HYSD bars, this it might be 415, it might be 500. Then in that case, the value will be 230. You can see from this table. Sigma st value will be 230 in that case. Okay. Do you have any confusion in that? How to choose sigma st values? If you have any doubt, you can ask me now. Hello? Okay, so let us move to the. Okay, let us move to the next part. Okay, okay, so this M is your modular ratio. Okay, so from these two triangles, you can see these two triangles are similar triangles. Then we can use the property of similar triangle. Okay, so no need to remember these formulas. Okay, this final formula you have to remember. Okay, this final formula you have to remember. That means in case of single reinforced beam, okay, this formula is valid. M into sigma CBC divided by sigma ST divided equal to N divided by D minus M. M means your modular ratio, which we have discussed in the last class. Sigma CBC means characteristic compressive strength of concrete in bending. Then sigma ST means stress in steel, permissible stress. Okay. This N means depth of neutral axis. This D means effective depth. Okay. So this is the formula we can derive, okay, from you by using the properties of similar triangle. Okay, this is a derivation given. Okay, so then again, this neutral axis corresponding to permissible stresses of concrete and steel is called critical neutral axis. Okay. So here in this not only in this chapter, in the next chapters also, we have to understand two terms. One is your actual neutral axis, another one will be your critical neutral axis. Okay, so this actual neutral axis means, okay, I will discuss it later on. I will show you how to find out what is actual neutral axis and what. Okay, so this critical neutral axis means when both steel and concrete are, you can see here, corresponding to permissible values of stresses. Permissible means, the meaning of the word permissible means maximum. Okay, so if you are considering the maximum value of stress for concrete and steel, then in that case, whatever neutral axis you will get, that will be known as critical neutral axis. Okay. If you are considering sigma CBC from IS code and sigma ST from IS code, so in that case, whatever neutral axis you will get, that neutral axis will be known as your critical neutral axis. Okay. So there is a formula for critical neutral axis, NC, it will N for neutral axis, C for critical. Okay. So it will be, there is a formula equal to K into D. K is a factor, neutral axis depth factor. Okay, no need to remember the value. You will get the values in the later part of the PDF. I will show you how to find out. So if you put the value of N and or NC here in this formula, then and in place of N you put KD. Here also you put KD. Then again, if you simplify, you will get the value of K equal to this one. Then again we know that M equal to, in the last class I showed you, modular ratio has a value. Okay, 280 divided by 3 sigma CBC. If you put the value here, then if you simplify again, you will get this one. Okay, so these are the two different formulas to find out the value of K. K means it is a factor. Okay, it is a neutral axis depth factor. K have different values based on these values. Okay, if M value is given, some of the students are waiting in the chat box. Okay, and all of you do one thing, you write down your name and enrollment number in the chat box. Okay, all of you, please write down your names and enrollment numbers in the chat box. Okay, so let's continue our class. Okay, these are the different K values. Next, okay, I will discuss this to find out percentage of steel. I think you can understand what is percentage of steel. That means how much steel we have to provide in a single reinforced beam. This is the formula by which we can find out. ETU is percentage of steel. K means is your neutral axis depth factor. M means your modular ratio. Next, one thing you have to understand. In the last class also I told you. Again I will tell you now. So this is our stress diagram. Okay, this is our stress diagram. This is our concrete part. This is our steel. Okay, so the entire maximum total compressive force will act along in this part, and the total tensile stress will be taken up by steel, and which is indicated by T here, and the total compressive force is indicated by C. Okay, so this C will act at a certain point. This total T, total compressive force of this entire section will act at a certain distance. Okay, and this distance, you can see in this diagram, this distance is n by 3. If this height is your n, which is your neutral axis depth, then this total compressive force will act at a height of n by 3. Okay, and this is the total tension. As you know that the entire tension will be taken up by steel. That's why this is our total steel, total tensile force. Okay, so this lever arm is nothing but the distance between the total compressive force and the total tensile force, this distance. Okay, lever arm you can see here. You can read the definition also. Lever arm is the distance between resultant compressive force and the resultant tensile force. Resultant compressive force is this one. Resultant tensile force is this one, and the distance between them is known as lever arm. Okay, so we will indicate lever arm by this letter, small a. Okay, so small a will be this whole length. This total depth was, as I have shown you in the previous diagram, this whole depth was D. Okay, and C is acting somewhere here at a height of n by 3. Then this remaining depth will be D minus n by 3. You can see here. This is our total D, small d, effective depth. This distance is our n by 3. So our lever arm value will be D minus n by 3. Okay, so now lever arm you can see here, and also this again we can express a means our lever arm by another formula, which is equal a equal to J into D. Again this J is known as lever arm depth factor. Okay, this is a factor whose values are constant for a particular steel and particular grade of concrete. I will show you what are the values of J and what are the values of K. Okay, so now if you put a equal to JD in this formula, we can find out the value of J here. J equal to 1 minus K by 3. Okay, so now I think you have understood that if J value is given, we can find out the value of K. Similarly, if K value is given in the question, we can find out directly J. Okay, so this by this relation you can say both J and K, they are interrelated. That means K was our neutral axis depth factor, and this J is known as our lever arm depth factor. So both are interrelated to each other. Okay, by this formula we can find out if one value is given, we can find out another one. So next one is very important. This term is known as momento resistance. In exam, you can expect around two questions from momento resistance. Okay, so you can put a star mark in this topic, moment of resistance. Okay, so I hope all of you have pen and paper with you. I hope all of you have pen and paper with you. So if you, whatever I am saying, that this topic is very important, this moment of resistance. So I hope all of you will note it down, moment of resistance. Okay, in exam you will get at least minimum two questions from this topic. Okay, minimum two questions from this topic. Okay, so this moment of resistance, you can see the definition. It is the resistance offered by the beam against external loads. Okay, it is the resistance offered by the beam against external loads. Okay, let's just wait 1 minute. Okay, so this moment of resistance, you can read the definition. It is the resistance offered by the beam against external loads. Okay, so you can see here, as there is no resultant force acting on the beam, that means the section is in equilibrium. Therefore, total compressive force equal to total tensile force. C equal to T. Because our beam is in its own position, it is not moving. So we can say that our beam is in equilibrium, and therefore we can equal this compressive force and tensile force. Okay, so C equal to T. Put the value of C equal to T. C value is this one, half sigma CDC B into N, and T value is this one. Okay, so this total compressive force will act at a height of n by 3, which is written here, and total tension T equal to sigma st into AST. Okay, so can anyone tell me how this formula, how you are getting this formula? Can anyone tell me how you are getting? This T means total tension force. Okay, total tension force.
Excuse me, sir.
Okay, so can anyone tell me this, how you are getting this formula? Anyone? T means total tensile force, sigma st means stress in steel, AST means area of steel. So, how this formula you are getting? Can you tell me from which formula we are getting this?
Sir,
Yes.
so, my friend wants to re-enter because his laptop battery died, so he wants to enter again in
There,
the meeting.
yeah, there is no one in the with. Oh, Long Kumar. Buruapang.
Yes, Bro Longo.
Okay, okay.
Yes.
Okay. Okay, so now you tell me this one what I'm asking, but how you have got this one? Can anyone tell me? Anyone? Can anyone tell me how you have got this one?
Sir, that one is stress equal to force by area.
Yes,
That
good,
formula.
good. Yeah, good, good. Stress equal to force by area. This is our stress. Stress equal to force. This is our T divided by area. So if you find out the force, then it will be stress into area. Okay. So similarly here also. Okay. This is our triangular portion. So we have find out the triangular area. Then we have put the value. Then after that we have got this formula. Okay. So next we will equate this C and T. Okay, so now as I have told you, this moment of resistance, this is nothing but our, you can say indirectly, it is our, it is a moment. Okay, and in the last semesters, I think in third sem and fourth sem, we have studied about shear force and bending moment. Is it? Okay, so what is the
Sir,
definition? Yeah, what is the definition? How can you find out bending moment? How can you find out bending moment? Can you tell me how to find out bending moment? How to find out bending moment? You forgot everything, or you have studied something in the last semester. Bending moment. What is the formula to find out bending moment? Shirodha, at least someone, please tell me how to find out. Or if you don't know, please tell me. I will do it.
Sorry, we don't know. We forgot.
Okay, so
sir,
yeah,
sir, force into
yeah, force into,
and
yeah, force into,
distance.
yeah,
It
good,
is
good,
the
yeah, okay, okay.
uh, given.
Okay. So simple formula is bending moment is force into distance. So here we have two forces, either tension or compression. Okay. And which distance we have to consider to find out this moment of resistance? Anyone? Can you tell me which distance we will consider to find out moment of resistance?
Tension.
Our tension is not a distance, it is our force. So our formula of bending moment is force into distance. So either we can consider this tension force or we can consider this compressive force. But which distance we will consider to find out bending moment? Which distance we will consider to find out bending moment? Which distance? We can see a lot of distances are there. This n by 3, this n, capital D, this a. This which distance we will consider? Can you guess?
D minus N by 3.
N by
But
3. Okay.
for that compression,
Yeah. Any other answer? B.
A equal to D minus N by 3, sir.
Yeah, good. We have to consider this lever arm. Okay. Because you can see, that's why I am showing you the video. It is written here. The total compressive force is equal to total tensile force. Then you can see here, these two forces will form a couple. Okay, so do you know what is couple? Do you know what is couple? It is written here. See, equal and opposite separated by a distance. That means if two forces are equal, here our compression and tension are equal, is it? And they are separated by distance, by some distance. We don't know what is the value of this A, but they are separated by some distance. Then what will happen? They will form a couple. That means this will try to rotate this beam in this way. This force will try to rotate this beam in this way, in this direction. But since they are same, okay, since they are same, it will be in equilibrium. Okay, so if we multiply this C into this distance, then we will find out a couple. Or if T into A, that means this force into this distance, we will find a couple. The values will be same because C and T are same. Okay, and that couple is known as our moment of resistance. See here, the moment of this couple is equal to the resisting moment or moment of resistance of the system. Okay, so couple is nothing but our moment. Okay, force into this distance, that is our couple, and this couple will be known as our moment of resistance. Okay, so now you can see here, yeah, you can see moment of resistance equal to C into A or T into A. Okay, because our C means our total compressive force and T means our total tension force. Since both were same, so we can find out moment of resistance by force into distance, or T into A or C into A. So now we have to find out the value of C. Just put the value here. MR equal to, if you use this formula, if you put the value of C, then you will get this one. Or if you use this T, then you will get this one. Okay. So therefore we have two equations for moment of resistance. You can see equation number 4 and equation number 5. Okay, So in equation number this one, in equation number 4, if you put n equal to this n equal to kd, which I have already shown you before, n equal to kd, if you put the value here, then if you simplify it, if you simplify this equation, then you will get it. You will get this one. M r equal to half sigma cbc will be there. B will be there in place of n. You put kd. Here also you will put kd. Then you take some common. Okay. Here you can take a into bd square. If you can simplify this one, you can take d common here. You can take d common. Then if you simplify, then you will get this one. Half sigma cbc k. This 1 minus k by 3 is nothing but our j. It is written here. Hello. Okay, so this is the final formula we will get. Right? Then in this whole formula, this half is constant. Okay, half is constant. Sigma cbc is constant, which we can find out from I square. This k is also a constant. This j is also a constant. So we can say this entire term is a constant for a particular grade of steel and particular grade of concrete. Half sigma cbc k into j. This whole term is a constant. So this constant we will write here as R. Okay, see here, R is called a resisting moment factor, and this R is equal to half sigma cbc k into j. This one. Okay, so we have got the final formula for momento resistance. Mr equal to R B d square. R means this value, B means the width of the section, D means our effective load. Okay. Okay, so let us see this one. Okay, so now there is a table, this table. Okay, so now in the last class I told you how to find out the value of sigma cbc. How to find out sigma cbc? I told you if M20 grade of concrete is given, from table number 21 you can find out, from this table we can find out the value of sigma cbc. See, sigma cbc is 7. So if you get the value of sigma cbc, you can find out the value of M. You can find out the value of M. I am considering say M20. Okay, you can consider anyone. Just I am showing you one example how to find out these values. If you are considering M20, sigma cbc you will get from IS code table number 21. Then you will get the value of M. M equal to, I show you the formula, 280 divided by 3 sigma cbc. From that formula you will get the value of M. Then if you are using mild steel, okay, if you are using mild steel, see the value 140. Okay, see the value 140 mild steel. Yeah, this value. Sigma st value will be 140. Okay, sigma st value will be this one, 140. Then then you can find out k, then you can find out j, then you can find, if you put the value of everything sigma cbc k j b d square, everything if you put here, you will find out the value of r. Then you can find out this pt also from the formula given before. I'll show you the formula before this, from this one. Okay, so no need to worry, I will share this pdf in your group. Okay, after the class I will share with you this pdf. You can go through it later on. Okay, so next, very important, after momento resistance in this chapter, there is another very important topic, is balance, under reinforced and over reinforced sections. You can put star mark in this topic. Okay, balance section, under reinforced section, and over reinforced section. You can put a star mark here. You will get at least 1 or 2 questions from this balance section or under reinforced section or over reinforced section. You will get at least 1 or 2 questions from balance section or under reinforced or over reinforced. Okay, so now you can read this PDF. I think all of you can read it. What is the meaning of this balance section? You can read here. It is written. All of you please read it. In the meantime, let us take the attendance. Okay? Just wait for 2 minutes. You just go through the theory. I will give you the attendance. So those some of the okay. So balance section means you can read this balance section. Balance section means a balance section is that section in which stress in concrete and steel reach their permissible value at the same time. Okay, this means that the stress diagram in 2.6b, where the percentage of steel corresponding. You can see this figure. All of you, please try to understand this figure. Okay. This is the okay. This is our section. This is the width of the beam. This is the effective depth. These are the reinforcements we have. This is the critical neutral axis. That means I told you what is our critical neutral axis. Means if you consider the maximum permissible values of steel and concrete at the same time, then the neutral axis will be known as critical neutral axis. Okay. So now this is the diagram for balance section. So in the what is the definition of balance section? That means according to the definition, if the permissible stresses of steel and concrete both will reach at the same time, then the section will be known as our balance section. Okay, so balance section is nothing but if the steel and concrete both will fail at the same time. Okay, if in other words we can say if steel and concrete both will fail at the same time, then the section will be known as our balance section. Okay, so I told you before also what is the permissible, what they mean by permissible stress. That means it is the maximum stress. So as soon as steel will reach its permissible stress value, then your steel will start to fail. Okay, so similarly, as soon as permissible stress value will be achieved in this concrete, that means if we are considering M20 grade of concrete, then what is the value of sigma CBC? From the IS code, we can say that the value of sigma CBC is how much? 7. Okay, so 7 Newton per millimeter square. That means that is the maximum value which an M20 grade of concrete can resist. Okay, that is the maximum stress which M20 concrete can resist. Maximum stress which can be developed within an M20 grade of concrete. So as soon as 7 Newton per millimeter square stress will be released or reached in the concrete, then what will happen? You can see some cracks are developing in this concrete. Okay, in this concrete portion, that means at the top surface of the beam, you can see some cracks are developing. That means you can say that the maximum stress has been achieved. Similarly, sigma ST value, I have shown you sigma ST values. So if you are using mild steel, that means the maximum value of steel in the maximum value of stress in steel is 140. Okay? So similarly, if 140 Newton per millimeter square stress has been reached in this steel, then you can see some cracks are developing, or you can see some cracks are developing. So you can say that at that time, the stress in concrete and stress in steel is achieved. Okay, that means maximum stress has been developed since they have started to failing. Okay, so according to the definition of balance section, if maximum stress in steel and maximum stress in concrete both will attain at the same time, then we will say that the section is balance section. And in the balance section, whatever neutral axis you will get, that will be known as our actual neutral axis. This depth will be actual neutral axis. Okay? So in case of balance section, you can see from this diagram, critical neutral axis and actual neutral axis values will be same. You can see the condition here. Balance section. In case of balance section, you can see the balance section n equal to nc. Okay, n equal to nc. That means actual neutral axis depth and critical neutral axis depth will be equal. Okay. So next is known as your under reinforced section. Under reinforced. Can you tell me the meaning of under? What is the meaning of under? What is the meaning of the word under? I hope no one will answer it. Okay, so let me say this. Under reinforced means whatever reinforcement is needed in balance section, you are providing less amount of steel. Okay, under reinforced section means whatever reinforcement is needed in balance section, you are providing less than that amount of steel. So in that case, our steel will fail first. Okay, but at that time, the maximum stress in concrete will not attain. Okay? So you can say if you're using mild steel, say if you're using mild steel, say at a particular time when the stress in the steel will be 140, so in that time, at that time, the value of this sigma CBC will not be equal to the permissible. Say if you are using M20 grade of concrete, sigma CBC value is 7. So when the stress in steel will be 140, at that time the value of sigma CBC will not be 7. It will be less than 7. Okay, this line will indicate that. Okay. So when steel will attain its permissible value means when stress in steel will reach its permissible value. At that time,
Excuse me, sir.
yes. Hello.
Sir, can you explain this one under reinforced section?
Okay, okay. So let me see. Let me show you the definition. Yes, see the definition. In an under-reinforced section, the percentage of steel provided is less than that provided in balance section. I hope you have understood this line. Means whatever reinforcement we are providing here, in under-reinforced section, we will provide less amount of steel than this balance section. Okay. So in that case, what will happen? Our steel will fail first. Since we are providing less amount of steel than balance section, then steel will fail first. Okay, so you can see that value sigma st when stress in steel will be sigma st, that means maximum stress. At that time, stress in steel will not be sigma cbc, it will be sigma cm. That means this value is less than sigma cbc. Okay, so then in that case, if you connect these lines, this line and this line, if you connect this line, you can see the neutral axis has been shifted upwards. The actual neutral axis has been shifted upwards. Previously, this n was here along this line. Now, since our steel is failing first, so as a result of that, you can see our neutral axis is shifting upwards. Okay, so you can see the relation. Actual neutral axis depth will be less than critical neutral axis. Here, you can see the value. You can see the relation. Here, actual neutral axis depth is less than critical neutral axis. Okay, so this is the, you can see the definition also here. So the actual neutral axis will shift upwards. So, previously for balance section, this n was here and c was also here. That's why they are equal. But now since our steel will fail first, then if you connect the lines, you can see our neutral axis is shifting upwards. Okay. As a result of that, actual neutral axis value will be more than, okay, less than critical neutral axis. From this diagram you can see n is less than nc. Okay, so in an under-reinforced section, if I ask you in an under-reinforced section, how to find out moment of resistance? Can you tell me which formula? we have two formulas to find out momentum resistance. These two formulas. In an under-reinforced section, which formula you are going to use? Equation number 4 or equation number 5? In an under-reinforced section, which
Sir, 4,
4? Why 4? Yes, why 4?
because compression.
No. Any other answer? Any other answer? Anyone have any other answer? Okay, if you don't speak, at least write in the chat box, okay? Otherwise, it is very difficult for me. If you don't know the answer, please write down at least in the chat box or you speak up, okay? Otherwise, it is very difficult for me to make you understand. Okay, so we have to use for under info section, we have to use question number 5. We can't use this one because this equation we will use when concrete will fail first. Okay, sigma CBC is the stress in concrete, not in steel. In under info section, our steel will fail first. That's why we have to use this equation to find out moment of resistance for under info section. You can see here, you can see the formula in this way. See this one. We are using sigma ST, not sigma CBC formula. The moment of resistance is calculated by this formula. Okay, so these are the various features of under reinforced section. So the features are, as I have already told you, steel is fully stressed while concrete is not. That means when stress in steel will be sigma ST, you can see here, but stress in concrete is less than sigma CBC. Okay, when the stress in steel is sigma ST, that means permissible means maximum, but stress in concrete will be less than sigma CBC. Then the actual neutral axis lies above the critical neutral axis. This is the actual neutral axis will lie above the critical neutral axis. Then the percentage of steel is less than the balance section, hence it is economical. Then it is known as ductile failure. In under reinforced section, if our beam will be failed, then the failure will be ductile. Okay, so do you know the meaning of this ductile? If I say this is the property of metal, ductility. So do you know what is the meaning of ductility?
Sir,
Yes.
I think ductile means which can be easily from shaped in the different forms.
No, no, that is known as malleability.
Oh yeah, yeah.
Yeah,
Sorry.
it is known as malleability. But ductility means we can stretch it more. Okay, we can stretch it more. We can stretch along, means deformation will be more in our this one. Uh, for all the metals, they are ductile because we can stretch it. You can see, as you can see, one. I can give a simple example of rubber. You can stretch it a long length, is it? Your actual length of rubber is a very small one, but if you stretch it, you can see it will become very long. So similarly, we can stretch our metal to a very long distance. Okay, so that is that nature is known as ductile nature or ductility. Okay, so whenever our section is under reinforced, then the failure will be ductile. So ductile means it will not suddenly fail. It will fail slowly. Okay. So say you have constructed a beam which is under reinforced. So after some time, if the failure will occur, you know that the failure will be ductile. Ductile means you will get a lot of time to before collapsing of this beam. You will get a lot of time to vacate this apartment or vacate this house. Okay. So in under reinforced section, here you can see in under reinforced section the failure is ductile because steel fails first and sufficient warning time has been given before collapse. Due to the ductile failure and economy, the under reinforced sections are preferred by designers. Okay, so that is the most important thing about this under reinforced section. And the moment of resistance is less than balance section. Okay, so these are the various features of under reinforced section. Then we have over reinforced section. So by the name itself, you know that In over-reinforced section, the percentage of steel provided is greater than the double section. Okay, so you can see in the diagram, if your steel is more, your steel will not be failing first. Our concrete will fail first. It means stress permissible value in stress, permissible value of stress in concrete will reach first, then permissible value of steel will reach. Okay, so here you can see the definition. In this section, stress in concrete reaches its permissible value while steel is not fully stressed. Okay? So we know that our concrete is a brittle material. So whenever you are using over-reinforced section, then it suddenly fails. Okay, as steel is not fully utilized, the section is uneconomical. Steel is much costlier than concrete. Okay, so the various features of this section are: concrete is fully stretched, but steel is not. Actual neutral axis will be below the critical neutral axis. You can see from the diagram. This N is our actual neutral axis depth. This is our critical neutral axis. So in case of over-reinforced section, this N will shift downwards. Actual neutral axis will shift downwards, and as a result of that, N value will be more than critical neutral axis. Means actual neutral axis depth will be more than critical neutral axis. Okay. So these are the various. Okay, so now we can find out moment of resistance by this formula. We can see sigma CBC here, because in over-reinforced section our concrete will fail. That's why we have to use this formula, not that sigma ST formula. Okay, and here the failure will be sudden. That means you will not get any time. Your building might collapse suddenly. So as a result of that, it is very dangerous. This over-reinforced section is very dangerous. So we will always, you can see here, designers prefer this under-reinforced section because it will give you sufficient time before collapse. So in that sufficient warning time, you can vacate the building or apartment. So it is very safe, under-reinforced section. So always we will go for under-reinforced section. Okay. Otherwise, if you go for over-reinforced section, your building will be safe. But whenever during earthquake, or if due to any difficulty, whenever it fails, your building will suddenly collapse. And as a result of that, people may lose their lives also. So it is very risky. So we will never go for this over-reinforced section. Always we will design an under-reinforced section. Okay.